Hey guys, it's me. All right. I have good news and bad news. Which do you want to hear? Let's start with the good news. The good news is because of distance learning, 10.3. Now, I know you guys, and if I had even attempted to teach y'all 10.3 in this kind of situation where I can't be with you guys while you're doing your homework, I mean, the stuff and being alone with it is bad enough, but 10.3, your parents would probably kill me. Seriously, even the ones that are sitting here watching the video probably wouldn't be too thrilled. It's pretty tough. So with that said, we're skipping 10.3. We're also skipping 10.5. You get where I'm going with this? You've done 10.1, 10.2. And today we're going to do 10.4. It's way easier to handle and understand than 10.3. It's okay, guys. In the situation that we're in, it's okay to skip around. You're getting the basics. Trust me, I'm not going to let y'all go on next year without knowing this stuff. Skipping 10.3 and 10.5, it's not going to hurt you. Trust me. But with that said, after we do today's, we're done with the chapter. You get where I'm going with this? That's right. So your test or your quiz that was scheduled for Monday, you're not having a quiz. You only got 3 sections of this chapter that you're going to be tested over. No reason to have a quiz. We're jumping right. We're skipping that. We're going straight to the test. Your test is scheduled, and I'm going to write this down now and at the end. Your test is now scheduled for Tuesday. Okay? It's only going to be over 10.1, 10.2, and 10.4. 3 sections. I think you can handle it. Y'all did your IXL and everything, and so that should be good. And I think you're going to be okay. Today's isn't too bad, really, trust me. So anyway, no quiz on Monday. Your test will be Tuesday. Got it? Okay, so with that, let's get going so we can get done. I have very little notes. I have more examples than I do written notes. So y'all should be happy with that as well. All right, so this one is 10.4. It's special patterns. All right, special patterns. For example, a squared minus b squared. We're going to be factoring out. That says factoring. The difference. Do you remember what difference means? Subtraction. So we're factoring the difference of squares. Okay? The difference of squares. For example, look at this one. When they say squares, they're talking about a squared, b squared, c squared, d squared, stuff like that. Squares. Anything that has an exponent of 2. Difference, right here. So I'm going to rewrite this. A squared minus b squared. Let me show you how to do it. It's not too difficult. You're going to write 2 parentheses. Okay? And remember that whole reverse thing. But anyway, a times a gives you a squared. B times b positive b times negative b gives you negative b squared. Now let's talk about that again. A squared, a times a, and that's a negative b squared, so positive b times negative b gives me a negative b squared. Now, you should be asking yourself, well, wait a minute, we've been doing this, but we always had something in the middle. Remember, those are trinomials. Watch this. So if I do a times a, I get a squared. If I do a times negative b, I get negative AB. See that? A times negative B gives me negative AB. Then if I do B times A, remember FOIL, okay? That gives me positive AB. Now this says B times A, but remember we write them in alphabetical order, okay? And then B times negative B is negative B squared. Circle your like terms. Again, remember, alphabetical order. These are like terms. Negative AB and positive AB. They cancel out. Negative AB and positive AB. They cancel out. So you're left with A squared minus B squared. And it checks. See that? All right, and don't worry, we're going to be doing a lot of examples. Now, let's do another thing here. It's called factoring perfect square trinomials. All right, so for example, if I had A squared plus 2AB plus B squared. All right, notice we're dealing with two positives. That's a good thing. All right, notice that we have an A squared here and a B squared here. So if they're both, listen to this, positives, if they're both positives and they're both perfect squares, then the answer is just A plus B squared. That's the same as saying A plus B times A plus B. You can check that out. Whoops, I should have skipped a line. A times A is A squared. A times B, move it up. AB, B times A, remember to put it in alphabetical order, plus AB, and then B times B is B squared. We circle our like terms. Remember, if we don't have a number there, we pretend there's a 1. So that's like saying 1AB plus 1AB. That would give us 2AB. And those check. All right? If you need to rewind and look at that again, you can. All right, so let's do another example of this. Now, this one, they had two, remember, perfect squares, two plus signs. Look at this one. A squared minus 2AB plus B squared. We have a minus and a plus this time. Okay, now, you may want to pause this and copy some of this down on paper so that when you're doing your homework, you'll have it right there to look at. I mean, you can have your video up too, but this stuff right here, these examples right here might be good to have when you're doing your homework. So you could even take a picture with your phone or something like that and have it with you. I don't know, whatever would work for y'all. Okay. So I have a perfect square there and a perfect square there. Keep in mind we have a negative and positive. Now the answer to something like this is going to be A minus B squared. It would be like A minus B times A minus B. And watch this. So you see the difference now? Two plus signs with perfect square trinomials, it gives you this with the plus sign. If you have a minus sign and a plus sign, you're going to have this. Same thing, you just have a minus. All right, so let's check. A times A is A squared. A times negative B is negative AB. Negative B times A, remember to put it in alphabetical order, it's negative AB. And then negative B times negative B is positive. Negative times a negative is a positive B squared. Now we combine our like terms. And remember, if there's not a number there, we pretend there's a 1. So that would be negative 1AB and negative 1AB. That would give you negative 2AB plus B squared. And that checks. Okay? Again, remember, when I start doing the examples, you'll start understanding it. That's why I really wanted to skip 10.3 and go straight to this. Okay, page 422, examples. Go ahead and open your book, if you haven't already, to page 422. Does that help? I don't know if it does or not. Okay. Look at number 13. That does not help. I can't see nothing. All right. So 13. All it says is factor. And that's what you're going to do. Don't worry about that other stuff. The section before that. We're just going to go straight to factoring. And that's the really confusing thing is when they don't tell you really what to do and all this stuff. They just say factor. And you got to just know what you're doing. It's a little bit different than the factoring you used to do back in 6th grade and stuff like that. This is a little different. Okay, so 13, they have a squared minus 225b squared. Okay, guys, that is a perfect square. That is a perfect square. And if you remember, perfect squares are like this, guys. Remember, square root of 4 is 2. Square root of 9, that's 3. Square root of 25, that's 5. Square root of 16, 4, and so on. Okay, does that ring a bell? All right, so that's what we're talking about, perfect squares. This is a perfect square. Believe it or not, this is a perfect square. Now, Algebra 1 is going to have big numbers like this. You do have calculators that you can use on this stuff. You heard right. You can use that right now. I don't care. So I want y'all to go ahead and you can put it in there and figure out what the perfect square is, or if it even is in your calculators. Okay, and if you don't know how to put that in your calculator, privately message me, because I don't want to waste everyone's time. Privately message me and I'll talk you through it. I think Allie took mine, but I'll find it. Okay, so this is how you write it. When it's a perfect square and you're factoring it out, you're not looking for what they have in common, because they don't have anything in common. You do your 2 parentheses. This is your perfect square, a times a. What times what gives you 225b squared? That's right, I'm not going to forget the b. It's going to be 15b and 15b. Because 15 times 15 is 225. B times b is b squared. Okay? All right. So the thing you're missing, though, is this negative. So you're going to put 1 negative there. You're going to put 1 positive there. Because remember, this is not a trinomial. These are trinomials where they have the number in the middle. Okay, so you don't want to cancel it out. These right here, they don't have a number in the middle because it's been canceled out. Remember, we had a negative and a positive. They cancel out, so you're missing that middle number. These, you cannot have that. they have to be a plus and a plus, or a minus and a minus. Oh, I'm sorry, minus and a minus, because you don't want to cancel them out. You want them to stay. So here you have to have one as a negative and one as a positive so that you know when you're done working it out, it'll cancel out. So let me go ahead and rewrite this, and we're going to check it because I really want y'all to make sure you check things. A times A squared. A times 15B, 15AB, positive 15AB, negative 15B times A, remember to write it in alphabetical order, negative 15AB, and then negative 15B times positive 15B. Negative times a positive gives you a negative. So 15 times 15 is 225. B times B is B squared. Circle your like terms, okay? And a positive 15AB and a negative 15AB, those cancel out. So then you're left with A squared minus 225B squared. And they check. So then this is your answer. Okay? Any questions? All right. Okay, here we go. I have a lot of examples, so be ready. 15. A squared minus 6x plus 9. You have a negative, you have a positive. You have a perfect square there, you have a perfect square there. Remember, perfect square. There you go. 3 times 3 gives you 9. Okay, so if you have that, you need to automatically know, if you go back over your notes, you would know exactly what to do. But just in case, I'm going to show you. X times x gives you that. 9, 3 times 3. And because it's a negative here and a positive here, it's going to be negative and negative. Look, notice they're both the same. So then it's x minus 3 squared. Let me show you. Here's your trinomial, 1, 2, 3. Perfect square, negative and positive. And here's how it's going to look. So if you notice, perfect square, negative, positive. All you have to do is write this. The perfect square for x squared is x. Perfect squared for 9 is 3. Because that's a negative and positive, you put a negative and square it. That's why I said it would actually be beneficial if y'all made sure you wrote down all of this and all of this, because then when your video is done, you can have this sit in front of you when you're doing your homework and match it up, and you could skip all this and go straight to that. Either way, that's how you do it. And if you want to, you can check x times x, x squared. Negative 3 times negative 3 is positive 9. Negative 3 times x is negative 3x. And x times negative 3 is also negative 3x, which gives you negative 6. Okay? Y'all can pause that and work it out. But you should be able to get to the point, watch this, x squared, where you don't even have to work it out, minus 16x plus 64. Question, Is this a perfect square? Yes. Is this a perfect square? Is there a number that when multiplied by itself gives you 64? 8. You have a negative and a positive, just like up here. Perfect square, negative, positive. So x minus 8 squared is your answer. See, if you start kind of memorizing that, then you can skip all the other stuff and go straight to the answer. Now, if you're not sure, I mean, because, like, let's say you're taking the test and you're like, man, I don't remember how to do that, then just work it out. X times x is going to give you x squared. Remember how the other day you wrote out all the factors and everything and all the numbers that when multiplied gives you 64? Well, we know that that is a perfect square. 8 times 8 gives you 64. However, there's a negative there. 8 plus 8 does not give you a negative 16. It gives you positive. So, negative 8 times negative 8 gives you a positive 64. Negative 8 plus negative 8 gives you a negative 16. So 8 and 8, negative and negative. You could check that. X times x, x squared. X times negative 8, negative 8x. Negative 8 times x, negative 8x. And then negative 8 times negative 8 is positive 64. Combine your like terms. You get x squared minus 16x plus 64. And it checks. So there's your answer. Okay? All right, 19. A squared minus 10ab plus 25b squared. All right, guys. Is that a perfect square? Yep. Is that a perfect square? Does anything times itself give you 25? Yep, 5. And b squared, b. So 5b times 5b is going to give you 25b squared. You have a negative and a positive, just like the first three that we did. Just like the first three. Trinomial, perfect squares, negative and a positive. So, a minus 5b squared is your answer. If you have perfect square, negative and positive, you can just jump right to it. Seriously. Again, if you don't know, then you would work it out. A times a gives you a squared. 5b times 5b gives you 25b squared. Then you just got to decide, what to put here, negative and negative. So negative times negative is going to give you positive. This plus this is going to give you negative. All right, 21. All right, here's where it gets kind of hairy. 2a squared minus 242. Okay, I know already you want to jump in there, but guess what? You first, now parents and students, pay attention. You first have to see if there's anything you can pull out first. Remember the very first 10.1 where you had to take out what they both have in common before you did anything? Well, you do the same thing here. What do they both have in common? Well, this has an a squared, but this doesn't have an a, so you cannot take an a out. This has a 242. So can you take, a 2 out of both? Yes, you can. 2a squared divided by 2 is just a squared. Or you can even say 1a squared. 2 divided by 2 is 1. I'm just leaving it out right now. 242 divided by 2 is 121. 2 goes into 2 one time. 2 goes into 4 two times. 2 goes into 2 one time. Okay? So 2a squared divided by 2 is just a squared. Now we can factor it more. Keep that 2 there and there. Don't get rid of it. Do your 2 parentheses. Question. Is that a perfect square? Yes. So a times a gives you a squared. Is that a perfect square? Yep. 11 times 11 gives you 121. Now this has a negative here. Go back to I call it the cheat sheet. Look at that. Perfect square minus perfect square. Perfect square minus perfect square. Look at the answer. Whoops. Perfect square, perfect square. Positive, negative. See that? I mean, you can even do negative and positive. I don't care. But positive 11 times negative 11 gives you negative 121. Look at this. 11a, positive 11a, and negative 11a. Those are going to cancel out, aren't they? Let's check. I'm going to rewrite it. Notice I'm keeping the 2 there. A times a. A times negative 11. 11 times a. Remember your your numbers go first still. Don't put a 11. And then positive 11 times negative 11. It's negative 121. Circle your like terms. Negative 11a and positive 11a, they cancel out. So you're left with a squared minus 121. And that would give you this right here. Which would give you this right here. Okay, so does that make any sense to you? So look back over it, rewind, because I am tired, y'all. I'm so sorry. It's 12:30 in the morning, and I'm still working. Okay, so look back at the beginning of this. This is what they gave you. Okay? I can see y'all sitting there like, what? This is what they gave you. The first thing we do is take out what they have in common. We took out the 2. Okay? So now we're left with this. So what we're going to do then is we've got to break it up even further. It's called factoring it out. Your end result should not have perfect squares in there. Like, look at this one. This one did not have perfect squares in there. Okay? It's the same as this. So some of you may be saying, how come this one has 2 parentheses and that's the answer, and this one has 1? And how come we didn't box that one? It has 1. Well, because in reality, it's 2 parentheses because it's squared. See that? So it's 2 parentheses. I will tell you, if you were to give me this as an answer, I would not count it wrong. Okay? I would not count it wrong. IXL, I don't think they would count it wrong. I really don't, because it's literally the same thing. Here, this is not the same thing. These are perfect squares that still need to be factored out. See the difference? This is just basically saying, well, they're the exact same thing, so you might as well just combine them into one parenthesis and put the exponent 2. So this is your answer. But this is the exact same thing, where this and this are not. These still have perfect squares that need to be factored out. I bet that helped. That explanation right there probably did help a lot. So you can't leave it like that. You got to keep factoring it out. If you are left with some perfect squares, you need to keep going. And that's what this is. And since that's a positive and that's a negative, we can't write it as just one. Okay, you see the difference? Okay, let's do another one. I'm a much better teacher when I've had sleep. Okay, 23. Okay, I'm awake. 9x2 plus 12x plus 4. Okay, this is a perfect square. This is a perfect square. Okay, so perfect square, both plus signs. So this, and actually, you don't even have to do that. If they're both perfect squares, remember right here, perfect square, plus and plus. That's your trinomial. Perfect square, plus and plus. So you could jump right to 1, since they're the same, 3x plus 2 squared. 3x, perfect square 4, 2, and then parentheses, and then that. Because inevitably it looks like this. 3x and 3x. 2 and 2. Both are plus, so plus and plus. Look, same exact thing. 3x times 3x, 9x squared. 2 times 2, 4. What's 2 times 3x? 6x. 3x times 2, 6x. Both plus, so you add them and you get 12x. All right, 25. Ah, yes. A squared, x squared, minus 16x squared. All right, guys. We have a negative. We have perfect squares. But we also have something else wrong. Can you factor anything out of here? Yes, you can. You can take an x out. You can take 2 x's out. There's a 2 at x squared here and an x squared here. So I'm going to take an x squared out, and I'm left with a squared minus 16. Okay, so we're looking to see what we can take out. All right, this is a perfect square. That's a perfect square. So can we leave it like this? No, we have to continue factoring. And notice that I'm bringing this with me. A squared. Now remember, there's a negative there. That doesn't mean we have negative negative. That's going to mean like we have a negative 4 and a positive 4. They've got to be different. And then we're done. Let's see. We started with 15, 25. I'm going to do just a couple more, and then I think I'm going to set you free. Look at 27. 9x squared plus 30xz plus 25z squared. All right, is there anything that we can take out that they all three have in common? No. Here's a perfect square, 3x, perfect square, 5z, positive, positive. So because they're both positive, that means it's going to be the same. 3x plus 5z squared. Square root of 9x squared is 3x. Square root of 25z squared is 5z. You can check that. 3x times 3x gives us 9x squared. 5z times 5z gives us 25z squared. Both plus, plus, plus. They're the exact same thing, so you can stop right here. If you give me this answer, it's correct. This is the same thing. So if this going right to here is making you crazy, don't do it. Last thing I want to do is make you crazy. If all of you just give me this, or like up here, if you were to give me this instead of that, I'm okay. I am A-okay with that. So did you hear me? I'm okay with that. 29. 16x squared minus 4. Can we take anything out? Do either one of these terms have something in common? Yes, they have 4 in common. 16, they don't have an x in common, just 4. 16 divided by 4 is 4x squared. 16x squared divided by 4 is 4x squared. Minus 4 divided by 4 is 1. Believe it or not, this is a perfect square. Think about it. 1 times 1. That's a perfect square. And I have a minus sign. So I cannot leave this alone. I have to keep going. And notice I have a 4 here and a 4 here. 2x times 2x. Negative 1, positive 1. 2x times 2x gives me 4x squared. Negative 1 times positive 1, negative 1. Negative 1 times 2x, negative 2x. 2x times positive 1 is positive 2x. They would cancel out. So there you go. All right. Now, this is kind of weird. Trust me when I tell you, it's easier than 10.3. Trust me on that. Trust me on that. So, you are doing page 422. You are going to do 1, 2, 3, 4, 5, 6, 7. Okay. You're only going to do 7 problems. 14 to 26 even. There are no primes. Oops, sorry. There are no primes. I'm looking at 14, 16, 18, 20, 22, 24, and 26. All right, guys. Be very careful. Pause the video when you're doing the stuff. Make sure that you write this stuff down. It will help you. It's like a cheat sheet, okay? So make sure you do that. All right, so remember your test is on Tuesday in your IXL. What'd I say? Monday. Okay? So if you have questions, if this is crazy, let me know. But you have all these worked out, okay? And you can pause the video and do it together. All right, take care. Sorry about this. This is madness. I didn't create it or invent it, so don't blame me. It's just weird. All right, take care.